Something unprecedented is happening. In September 2025, Earth is set for a wave of cosmic near misses. Asteroid 2025 FA22 will slip past us at just over twice the distance to the Moon, while 2025 RAJ2 surges even closer, less than 300,000 kilometers away. At the same time, dozens of smaller objects are being logged at sublunar distances in a single record-shattering week. And if that wasn't enough, 3I Atlas, a chemically bizarre interstellar visitor, is accelerating toward Mars on a trajectory unlike anything we've ever seen. The numbers defy probability. Is this just cosmic coincidence, or are we witnessing a pattern that could rewrite how we defend our planet? The answer might just change what it means to be a bystander in the solar system. September 2025 arrives with an unbroken string of alerts. Astronomers at the Minor Planet Center log asteroid 2025 FA22 at just over 2.2 times the distance to the Moon, about 835,000 kilometers. 3 days earlier, 2025 RJ2 slipped by even closer, a mere 0.78 lunar distances. These aren't isolated events. The week of September 12th to 18th shatters all previous records. At least 28 near-Earth objects pass within the Moon's orbit. That's triple the prior weekly high. Most are small, in the 8 to 25 meter range, the kind that could vanish in our atmosphere or explode like Chelyabinsk. But 2 FA22 and RAJ2 are large enough to demand global attention, with estimated diameters up to 120 meters. Each detection flashes across the screens of survey teams. Pan-STARRS in Hawaii, Atlas in Chile, the brand-new Rubin Observatory in the Atacama Desert. Data streams in from automated telescopes, processed by software tuned to catch even the faintest, fastest-moving blips. The pace is relentless. The Rubin Observatory, only months into full operation, is contributing a flood of fresh data, picking up objects that would have slipped by unnoticed just a year ago. Statistically, this is supposed to be a once-in-decades event. Population models put the odds of seeing more than 25 sublunar objects in a single week at less than 1 in 1,500. Even with improved detection, the September surge stands out a cluster that defies the usual random scatter. Some experts speculate about orbital resonances or a hidden breakup event in the asteroid belt, but most point to the power of new technology. Detection efficiency now exceeds 90% for objects larger than 20 meters within 1 lunar distance. Blind spots are shrinking, but they're not gone. Sunward approaches remain a weakness, a lesson seared into memory by the Chelyabinsk airburst. On social media, the numbers fuel speculation. Charts circulate showing a spike that looks too sharp to be chance. In scientific circles, the mood is more measured but no less alert. Each close pass is logged, analyzed, and archived, feeding into a planetary defense system that is only as strong as its latest detection. And the question lingers, what if just one of these objects had been aimed a little closer? Imagine FA22 hadn't missed. At 120 meters across, it would begin its entry high above the atmosphere, a silent speck hurtling at over 18 kilometers per second. If it were a stony asteroid, it would compress the air ahead until the pressure shattered it in a violent airburst. Much like Chelyabinsk, but carrying more than 20 times the energy. The explosion, at an altitude of 10 to 20 kilometers, would release energy equivalent to several megatons of TNT. The shockwave would flatten buildings across dozens of square kilometers. Glass would shatter, walls would buckle, and the heat flash could ignite rooftops. But if FA22 were made of iron, the story changes. Denser and more cohesive, it could punch straight through the atmosphere, striking the ground at nearly full speed. The result? A crater hundreds of meters wide, a fireball visible for miles, and a plume of debris lofted into the stratosphere. Now, shift the target to the ocean. Over 2/3 of potential impact sites are water. The energy would transfer into a massive steam plume and a series of tsunamis radiating outward. Coastal regions within a few hundred kilometers could face walls of water tens of meters high. Ports, cities, and low-lying islands would face catastrophic flooding with little warning. The Chelyabinsk event exposed our blind spot, objects approaching from the direction of the sun. Sergei Karpov, whose dashcam footage became an icon of that morning, still describes the aftermath in terms of noise, glass, and confusion. His message is simple. The line between a harmless fireball and a city-leveling disaster is thinner than most of us realize. Comet Swan presents a different kind of spectacle. Discovered on September 11, 2025, not by a telescope, but by the SWAN instrument aboard the SOHO spacecraft, its arrival was announced by a sudden surge in hydrogen emissions. This ultraviolet fingerprint lit up the data streams before most ground-based observers even knew to look. A handful of backyard observers confirmed what the satellites had hinted. SWAN was brightening fast, its tail doubling in length overnight. Spectroscopy revealed a volatile-rich coma dominated by hydrogen. The outgassing rate spiked as it neared the sun, with hydrogen production outpacing water vapor by a factor that caught even seasoned comet watchers off guard. The reason? SWN's icy nucleus was fragmenting under the solar heat, exposing fresh layers and releasing trapped gases in a series of outbursts. Professional observatories scrambled to schedule follow-up observations. Meanwhile, citizen scientists continued to feed data into the pipeline, timing outbursts and mapping the tail's morphology. As September drew on, the risk of complete fragmentation loomed large. Recent models suggested its nucleus, already riddled with fissures, might not survive its closest approach to the Sun. If it broke apart, the resulting debris cloud could produce a spectacular display. For planetary defense teams, SWAN's volatile behavior served as a reminder: not all threats travel on silent, predictable paths. Sometimes the warning comes as a sudden burst of hydrogen. April 13, 2029 is already circled in red on every planetary defense calendar. On that day, the asteroid Apophis will pass just 32,000 kilometers from Earth's surface, closer than many communication satellites and visible to the naked eye. For years, Apophis was the stuff of doomsday headlines. But the threat of impact has faded, replaced by a rare scientific opportunity, a live rehearsal for planetary defense, with the world watching. Earth's gravity will reach out and tug at Apophis, raising tides not of water, but of rock and dust. Scientists expect to see real changes: surface landslides, a reshaping of the asteroid itself. These tidal effects have never been measured up close on a body this size. To capture it, NASA has dispatched the OSIRIS-APEX spacecraft to rendezvous with Apophis soon after the flyby. Its mission: document every scar, every rearranged boulder, every trace of Earth's invisible pull. For Andrea Riley, a systems engineer on the team, the approach carries personal weight. In a diary entry from 2022, she recalled the anxiety of watching Apophis dominate the news as a teenager. That sense of dread now fuels her work. Apophis is a dress rehearsal for humanity's ability to track, model, and if ever needed, deflect a real threat. As it races past, the world gets to watch planetary defense in action, turning a headline once filled with fear into a story of preparedness and discovery. Then there's 3IATLAS. It stands out from the very first spectrum. Pan-STARRS flagged its hyperbolic path, but it was the chemical fingerprint that sent scientists scrambling. Early data revealed a coma dominated not by water vapor but by carbon dioxide. The JWST confirmed it. Carbon dioxide production was nearly 20 times greater than water. For solar system comets, that ratio is usually flipped. The anomalies don't stop there. Spectra picked up a strong atomic nickel signal streaming from the coma, but iron, its near-constant companion, was mysteriously absent. Theories range from unique formation chemistry to the selective loss of iron during billions of years adrift between stars. In mid-August, the Mars Reconnaissance Orbiter caught a sudden flare and outburst that doubled the comet's brightness in less than 36 hours. Light curve analysis suggests a slow, tumbling nucleus, making it even harder to predict its behavior. Each new dataset adds another layer of intrigue. As it heads for its closest approach to the Sun, the world's spectroscopists are in a race to record every detail. For now, 3IATLAS remains a chemical outlier, a slow-spinning messenger from a colder, darker corner of the galaxy. From a swarm of near-Earth asteroids to a fragmenting comet and a bizarre interstellar visitor, September 2025 is a powerful reminder. Our solar system is a dynamic and sometimes chaotic place. But with each new discovery, each close pass, and each strange new object, our ability to see, understand, and protect our home grows stronger. Thanks for watching. If you found this journey into our cosmic neighborhood as fascinating as I did, don't forget to like, subscribe, and hit that notification bell for more deep dives into the universe.